All right, so today we are looking a little bit more in depth at angle relationships. So first we're looking at adjacent angles. So adjacent, if you think about it just in our normal vocabulary, it means close to, close proximity to, nearby. So we're just transferring that to our geometry vocabulary. So adjacent in geometry means, first off, those angles, they have to be coplanar. They have to be on the same plane. So coplanar angles, they also have to have a common vertex. So they have to have the same vertex. They have to have a common side, so they share that common side. And then the last criteria is that they can't have any interior points in common. So no overlap between them, no interior points in common. So I could write that as no overlap. Okay, and one other thing to tuck in right here is just linear pairs are always adjacent angles. So anytime we see a linear pair, we know that it's going to be also classified as adjacent. So linear pairs are always adjacent. Okay, so linear pairs are always adjacent. So now in example 1. Determine which of the following are adjacent angles. Circle all that apply. So first we're looking at SPT. So SPT right here and TPM. Are those adjacent? Are they coplanar? Here's my plane. Yes. Do they have that common vertex? Yes. Do they share a common side? That would be that side right there. Yes. Okay. Do they have any overlap between them? No. Right? There's a point here that would be not inside of the other angle over here. So we'd say, absolutely, those are adjacent angles. Okay, how about SPT, SPT, and TPO? Well, yeah, also going to be adjacent angles. They're coplanar. Here's the common vertex. Here's the common side. And there's no interior points that they share in common, no overlap. So if I pick a point over here, right, that's not going to be in the interior of the angle that's over here instead. So we are good there. How about SPO, SPO, and TPM? Right, those would not be because, well, really two reasons. Let me just draw it out. So SPO would kind of look like that. And then TPM would look like that. I'm just drawing them separately. So I'm looking at that angle here, and then I'm looking at this angle here. So they don't have that common ray, that common side, and if I picked a point right here, it would be in the interior of both angles, so not adjacent, doesn't have that common side, also would have interior points in common. So we're going to give that a big X, no. Okay, how about 2 and 3? Well, those are linear pair. Linear pairs are always adjacent, so we like it. Box away. 2 and 1, well, we know that they're coplanar. They're on the same plane. Common vertex, common side. There's no point in angle 1 that would also be in angle 2, so we are good, adjacent. Okay, 4 and 5. Well, 4 and 5, they don't have that common vertex, so sadly, no. And then 9 and 10, well, I'm giving you a 3D model right here. So if I pull another 3D model right here, I'm looking at here and here. So those angles here and here. Would those be adjacent here and here? Well, no, right? They're not on the same plane. So big cross right there. So adjacent angles, they have to be coplanar. They have a common vertex, a common side, and there's no interior points in common, no overlap between them other than that common side. Okay, and we also know that linear pairs are always adjacent angles. Okay, next up, example 2. The complement of an angle is 5 times the angle. So I'm going to first define angle and complement with an A and a C. So the complement of an angle is 5 times the original angle's measure. Find the measure of the angle and its complement. So I'm defining the complement in terms of the angle. The angle is my x. And the complement is 5 times the angle measure. So it's 5 times x right here. And we're looking at complementary angles. So together they have to add up to 90 degrees. So complementary angles sum to 90 degrees. So I can build my equation that x plus 5x equals 90, or 6x equals 90. Divide by 6, and we get that x is 15. Okay, well, x is the angle itself, so the angle has a degree measure of 15 degrees. 5 times 15 is 75. Its complement would be 75 degrees. Together, these complementary angles have to sum back to 90 degrees, and they do. Okay, next problem. So here, an angle is 12 less than 3 times its supplement. So we're talking about an angle and its supplement this time. And we want to find both measures. So an angle is 12 less than 3 times its supplement. So the supplement is my x. And my angle is 12 less. So I'm going to take 12 away from 3 times, 3x. So 3x, take away 12. So I've defined it as 3x minus 12. So again, these are supplementary angles. They're going to add up to 180. So add up to 180 degrees. So when I build my equation, I can say that x plus 3x minus 12 sums to 180. So now combine the like terms. We got 4x minus 12 equals 180. I'm going to add the 12, and I have 4x equals 192. Okay, divide each side by 4, and I get that x is 48. So when I plug that in for the supplement, that one's easy. That's just 48 degrees. And then if I do 3 times 48 and then take away 12, I should get 132. Okay, so again, 48 times 3, that would have been, what would that have been? 146. No, 144. 144. 144, take away 12, and there's my 132. Okay, and then if I add these together, that sums back to 180. So I know that I've done my job because supplementary angles add up to 180 degrees. All right, next up. The number of degrees in a linear pair, so a linear pair, right, is a pair of angles, has to be a straight angle that's being split into 2 smaller angles. Okay, so number of degrees in a linear pair can be represented by 2 consecutive odd numbers. So consecutive means back to back. Consecutive would be like 1, 2, 2, 3, 3, 4, 4, 5. Those are consecutive numbers. Odd is like 1, 3, 5, 7. So if I want them in order and odd, it would be like 1 and 3, 3 and 5, 5 and 7, 7 and 9. Those are consecutive odd numbers. So back to back. Let me write down what I just said. So back to back. So for example, 1 and 3. Those would be consecutive and odd. Or 15 and 17. Also consecutive and odd. So I'm looking for 2 numbers. So I'll define it as number 1, number 2. So angle 1, angle 2. So I know that they are consecutive and odd. So let's say that I call the first one x. Let's say that I go back to 1 and 3. So if they're consecutive and odd, how far apart are they? Well, they're 2 units apart, right? They're always going to be 2 units apart. So my second one will be x plus 2. And since they form a linear pair, I know that that means 180. They have to add to 180. And now I can build my equation. I know that x plus 2 equals 180. So 2x plus 2 equals 180. Take away that 2. 2x equals 178. Divide by 2, and I get 89. So one angle would be 89 degrees. The other one would be 2 more than that, so 91 degrees. Okay, one other thing I want to point out, I actually could have defined it differently. I could have defined angle 1 as x, and I could have defined angle 2 as x minus 2. That would have worked out fine as well. I still would have gotten 89 and 91. Okay, they're consecutive, they are odd, they add up to 180. Okay, next example here. So here we're saying find the measure of x and the measure of RSA. So I'm trying to get to this angle in the end. I want RSA. This is what I'm trying to get to. I'm trying to keep my eye on the prize right there. There's RSA. Okay, what I have to be savvy to just in the very beginning is that, well, this is a straight pathway. This is a straight angle, which tells me that all of those together have to sum to 180. So a straight angle is always 180. So all of those smaller angles, their measures have to add up to 180. And I see this little tick mark notation, which means congruent angles. So this one also has to be negative 2.5x. I'm just going to add that to my picture. So now again, all these smaller parts have to add up to this larger whole. So I know that negative 4x plus negative 6x plus negative 2.5x plus the other negative 2.5x will sum to 180. So if I add up all of these numbers, I get negative 15x equals 180. Divide that negative 15 away, and I get that x equals negative 12. So x is negative 12. If I plug each of those back in then, this measure would be 48 degrees, here would be 72, here would be 30, and here would be 30. So those will sum back to 180, and the one that I want this one right here, that's 72. So x is negative 12, and the measure of RSA is 72. All right, please flip it over or pull out that second sheet. Here we go. Okay, so in this next example, I'm saying JT bisects angle PJM. So bisect means creates two congruent parts, two congruent angles in this context. So ray JT bisects angle PJM. So let's picture that. I don't know my scaling, so I'm just drawing a model. So here I'll make this P, here's a J, and here is M. And then I have ray JT right smack in the middle that's going to bisect it and create these two congruent angles. Okay, we're told that the measure of PJT here is 3 times x minus 12 degrees, and TJM here is half of x plus 39 degrees. So if I know that these angles are congruent, their measures have to be equal. So I can set these two expressions equal to each other. So I have 3 times x minus 12 is equal to half of x plus 39. And then I might just distribute that 3 just to see it nice and clean. So 3x minus 36 equals 1/2 of x plus 39. Okay, so now looking at it, I see, oh, there's a fraction. I don't love fractions, so I want to clear it. So I see that I have a 1/2 here, so I'm going to multiply everything by 2. So I'm going to double everything to clear that fraction. So what I do to one, I have to do to all of them to maintain the balance of my equation. So here I'm going to get 6x minus 72 equals x plus 78. Okay, so I want my x's together. I'll take x away from each side. So 5x minus 72 equals 78. Add that 72 to the other side. So 5x equals 150. And then divide by 5. And we get that x equals 30. Okay, I have solved for x. X is 30. So now let's plug that back in. So if I plug it back in here, 30 minus 12 is 18. 3 times 18 would get me 54 degrees right here. Okay, half of 30 is 15. 15 plus 39 will get me 54 as well. So good, that confirms that I've done my job, because if I'm bisecting an angle, I'm creating two congruent parts with measures that are the same. So these are both 54 degrees, right? And then the measure of PJM, this full measure, if I add those two 54s, that gets me 108. So that total degree measure of the larger angle is 108. Okay, example 7. Find x, then the measure of RSA. Okay, so first we want to get to x. So when I look at my picture, I'm thinking, well, these are labeled and these are vertical angles. So those angles that are in the opposite position, those are vertical angles, and vertical angles are congruent. So I know that I can set these two expressions equal to each other. So let me write that out. So I have 1/2 of x plus 40 equal to 3x minus 85. And I know that I'm going to want to clear my fraction, so I could do two things. I could clear it from this stage, or I could distribute first. It really doesn't matter. So in the previous problem, I distributed first. I'm going to do it the other way this time. So I'm going to go ahead and multiply each side by 2. So by doing that here, this now becomes 1, and I'm left with x plus 40. Is equal to 6x minus 170. Okay, so now I'll take the x away from each side. So here is 40 is equal to 5x minus 170. I will add the 170 to the other side. So 210 equals 5x. Divide each side by 5. And x equals 42. So I know what x is 42. So let me plug that in. 42 plus 40 is 82. Half of that is 41. This angle would be 41 degrees. And then here I want 3 times 42. So I have 126, and then take away 85, and I get 41 degrees as well. So I know that those two angles, they're the same. They have to both be 41 degrees. I know that x was 42. So the measure of RSA, I want this one. I want this one right here. So I have to see that, if I block this out, these angles form a linear pair. So together they have to add to 180. So 180 minus 41 is 139. Okay, and that would be the same right here. These form a linear pair. They'd have to add to 180 as well. So another way, just 180 minus this 41 would get me 139 as well, which means that this angle would be 139 also. So the measure of RSA is 139 degrees. All right, one more problem. All right, so in our figure below, V equals 2W. Okay, V equals 2W. W equals 2x, and x equals y over 2. We want to find y. I want y. Okay, one thing I want to point out too is where it says x equals y over 2 is really the same thing as writing it as 1/2 of y. Those are interchangeable structures. I'm just pointing that out to you. Now, I want to solve for y. That's my instruction. Find y. So I want to convert everything into y. And I'm going to end up using substitution in this problem. So let me just write that. So substitution will be the key to this problem. And I want to take a moment and convert all of my variables to y. Okay, so y is y. That one is good. X is half of y. So I'm just going to write this here, half of y. So now I have it in terms of y. So this is y, this is in terms of y. It's half of y. W is 2 of x, 2 times x. So if w is 2 of x and x is half of y, well, then really, just write that. So here's 2x, and if x is the same as half of y, I'm just dumping that right in here. I'm substituting it in. So w is the same as 2x, so I wrote 2x right here. X I've already established is half of y, so I'm dumping in a half of y in the place of x. And 2 times half of y is just y, right? 2 times 1/2 of y is just y. Okay, so now that angle is in terms of y. Okay, on to v. V is 2w. Let me write that, 2w. V is the same as 2w. Well, w is the same as 2x. W is also the same as just y. So if I swap that in right here, I have 2y right here in this slot. So I now have it expressed in terms of y. This angle is y, this is half of y, this angle is y, this angle is 2y, right? Again, not drawn to scale. So now if I add all those up, I know that this is a straight angle, a straight pathway will always be 180. So all of these smaller parts, they have to sum to 180. So I know that 2y plus half of y plus y equals 180. Okay, and then I want to clear my fractions. I don't like fractions, so I'm going to multiply every term by 2, right? Keep the balance of the equation. Distribute that out. So I get 4y plus 2y plus y plus 2y equals 360. So I get 9y equals 360. Divide by 9, and I get that y is equal to 40. Okay, so y is 40. Let me just double check to make sure that that works. So if y is 40, then I have 40 right here. Half of 40 is 20. Okay, here, this is also y. That would also be 40. And then 2 times 40 would get me 80. So if I take 80 plus 40 plus 20 plus 40, that will get me back to 180. So this problem is a little bit of a stumper. I'd probably put a little star next to it. You might want to watch that video one more time to make sure you understand how I'm using substitution to convert all variables to y. All right, that's all I have for today. Have a good rest of your day.